of slab, which is one way. We call it one way, no? Okay. Last time, what have we discussed? So you already know how to compute for the spacings of stirrups, no? And what is our basis in the design of the spacings of stirrups? Anyone? Anong nagiging basehan natin para dun sa spacings ng stirrups natin? Okay. At what region the spacing of stirrups is smallest or shortest? Ganyan. Okay, this is correct, no? Shear value, or particularly we refer it to the shear diagram. Okay, that is why you will notice that near the supports, okay, you have closer stirrups. Very good, Eliza. Tama yun, no? Mas masinsin yung mga stirrups natin, mas marami. And then when you approach the region where the shear is less, or even pag wala ng shear doon, the shear can have their maximum spacing, or at some portion, okay, when the ultimate shear at those portions are less than phi VC over 2, okay, you don't need any stirrups for those regions, no? Okay, sige. Now, for slab design later on, of course, we also have to have a basis kung ano ang slab reinforcements, no? What reinforcement are we going to place in our slab? Okay, later we will see that. Now, slabs are an important structural component where pre-stressing is applied. When we say pre-stressing, you know that already, no? We discussed that in the introduction. Okay. Slabs are used to provide flat or useful surfaces. Perhaps okay. Sa bahay ninyo, no, yung second floor, most of the residential houses which are two-story, kadalasan slabang na ano dyan, no? And they would usually say buhos. Pag buhos, that means that's binuhos yung ano, yung konkreto, no? That's actually reinforced concrete slab. And then if you were able to witness yung ano, yung construction ng slab, okay, there are reinforcements, no, that crisscrosses, no? Parang grill yan. It's like a grill at perpendicular directions. Okay. So these are flat surfaces, flat siya, and they are resting on usually beam. Okay. It says beam slab floor system. So you have the slab here. It's resting on the beams, and then these beams are resting on another beam where these beams are connected to the columns. Okay, so that if you have a load here, that is transferred to the beams that are supporting the slab, and then from this beams, they are transferred again to another beam in here, okay, or you call it girder. And then this girder, it transfers the load to the columns. Okay, and then from the columns, saan pupunta yung load? Hindi naka-drawing dito, ano? Pero I'm sure you're familiar already. So it goes to the foundations. No? And then from the foundations, it is transferred to the soil. Okay? So yun ang transfer ng mga loads natin. Yeah. What are the types of slabs? So first you have one way. Okay? And then two way. We'll know later what are one ways and what are two ways. And then you have flat plate and flat slab. Grade or waffle slab. Okay? What are one-way slab? It says here one-way slabs are those slabs with an aspect ratio in plan of 2:1. Okay? 2:1 yun. Or greater, it says. When you say greater, pwedeng 2.5:1, 3:1. Okay? In which bending is primarily about the long axis. When I say about, uh, it's the rotation is about means it's turning from the long axis. Okay? I hope you are getting that. Basically, yung bending mo noon, the deformation will be pronounced. It is pronounced, makikita ninyo doon sa shorter dimension. Okay? So the slab is one way where length over width is greater than or equal to 2. Okay? One-way slab may be solid, hollow, or ribbed. Okay? One-way slab, basically dito tayo magfo-focus of learning how to design yung slab. So we won't be designing two-way slab and the other types of slabs. Ayan. Ito yung hollow. Okay? Walang laman sa loob. And then you have the ribbed. Okay? Or itong rib parang marshmallow type, no? It says here, application of the length over width ratio. In this figure, slab is supported on two opposite sides only. In this case, the structural action of the slab is essentially one way. Okay, dito, this is the first one, no? You only have beams in here. Ito yung columns mo, and these are your beams. And then this will be your one-way slab. In the second figure, there are beams on all four sides with an intermediate beam. Meron kang intermediate beam dito. Okay. Now, if length to width ratio is 2 or greater, slab is one way, even though supports are provided on all sides. Okay. Even though there are supports, as long as the length to width ratio is 2 or greater, it is still one-way slab. And specifically, this is what happens. No? When slabs are supported on two opposite sides only, loads are being carried by the slab in the direction perpendicular to the supporting beams. Okay, ito yung sinasabi ko kanina. Ito yung supporting beams. No? And then, as I've said, yung deformation would be along the shorter dimension. Okay? So ang deformation niya would be like that. Or particularly, this is the elastic curve. Okay? It says here, when supports are provided on all sides, okay, most of the load is carried in the short direction. Ito yung short direction to the supporting beams, and one-way action is obtained. So minimal yung support nito, no? Although may two-way action siya, what is prevalent what dominates is this, no? Yung one-way action. Okay? For analysis, there is a term as a one-way slab is a set of rectangular beams side by side. Okay? Gets nyo yan? It's like you are designing uh, rectangular beams which are placed side by side. In the previous chapter 6 and 7, you've learned already how to design a reinforced concrete beam, whether it is singly reinforced or doubly reinforced. Alam nyo na yan, di ba? Kabisado nyo na yung formula doon. Okay, ganon din dito. But then, the width, we will be designating or yung beam niya, isa-set lang natin. You will see later on, we will be setting that to 1 feet or 1 foot. Okay? Ngayon, those 1 foot width beams will be placed side by side. Okay? And if these are placed side by side, that will make up a one-way slab. Okay? Now, particularly, these beams will be considered singly reinforced. Okay? You have seen earlier, no, when we discussed about doubly reinforced beams, meron konting complication dun sa analysis. No? But when we apply that in the design of slabs, saying that these are beams placed side by side, medyo simplified yung analysis na i-employ natin. Okay? For purpose of analysis, okay, there. A unit strip of such a slab is cut out. Ito yung sinasabi ko sa inyo, 1 foot, that's 12 inches, which may be considered as a rectangular beam of unit with, say, 1 feet or 1 meter. Pwede rin 1 meter, no? If we are using a metric unit with a depth of h equal to the thickness of the slab and a span L equal to the distance between supported edges. Ito yung L natin. Okay? From here up to there. The strip can be analyzed by the methods that were used for rectangular beams. Okay? So it says here, so that term is clear. Yun ang way of designing natin ng beam slab. I mean slab, one-way slab. Okay, for design purposes, there are some ACI code specifications, such as this one. No? To control deflection, it specifies minimum thickness values for one-way solid slabs. If we have simply supported beams, L over 20, ano natin ang minimum thickness. No? For one end continuous, that's L over 24. For both end continuous, you have L over 28. Okay, you know already when we say continuous, no? Okay? Pag nagko-continue siya doon sa isang end, okay, L over 28. I mean, L over 24. But for both sides, that's L over 28. And then for cantilever, that's L over 10. Now, notice what happens here. L over 24, what's the smallest sa apat na to? Yung continuous at both ends, no? It's like we are assuming that it's fixed on the left side, left end, and then fixed at the right end. Yun ang parang analogy nito, ano? That's why your requirement for thickness is less, no? If both ends are continuous. And then the greatest thickness would be when it is cantilever. Okay, you know very well if it is cantilever, pinakamalaki yung ano nito, yung maximum moment. Okay? What is the maximum moment of a cantilevered beam? Okay, unahin natin doon sa simply supported beam. What is it? Dapat memorize nyo na yan. Ah, what is it? WL squared over anyone? Maximum moment or simply supported? WL squared over 8 for simply supported. Now for a cantilevered, that's WL squared over 2. Okay? Kindly check that. No? Gusto ko ma-memorize nyo na yun. Yung mga maximum moments, maximum shear. Yeah. So, let me go back. Ito yung ano natin, ito yung guide natin on the initial thickness, no? Thickness value of your slab. And then it says the following minimum concrete cover is to be provided. It says concrete not exposed to weather or contact with ground. If you have reinforcements larger than number 36 millimeter bar, you have 4 centimeters. Number 36 millimeter and smaller, you have 2 centimeters. Ito yung cover, cover. When you say cover, you are measuring this from the top surface of your outer, yung nasa pinaka-outer surface ng reinforcement mo. Okay? Concrete exposed to weather or in contact with ground. Particularly, ito yung mga foundation, ganyan. O kaya yung mga tie beams. Anyway, this is a general provision for all concrete elements. No? Reinforced concrete elements. Hindi lang sa slab to. So, saan magpo-fall yung slab dito? Ito sa letter A. No? Okay, concrete not exposed. Okay, span. If the slab rests freely on its supports, the span length may be taken equal to the clear span plus the depth of the slab, but not to exceed the distance between centers of supports. Okay, yun ang ibig nating sabihin for span. Okay, now bar spacing. The lateral spacing of the flexural bars should not exceed 3 times the thickness H or 18 inches according to ACI code 7.65. Okay, so for the lateral spacing of the flexural bars, first, they should not exceed 3H. Okay, and then or 18 inches. And then it says here, the lateral spacing of temperature and shrinkage reinforcement should not be placed apart than 5 times the slab thickness or 5H, no? Or 18 inches, according to the ACI code. Okay? So, you will ask, sir, ano yung temperature and shrinkage? Yeah. We have flexural bars. No? The flexural bars should resist flexural stresses or moment forces. These are the length of the uh, about the length of the slab, or specifically they are perpendicular to the length of the slab. Yun ang flexural bars. Okay? If I may go back to the drawing para so that I can illustrate. Ayaw niyang bumalik. Okay. Sorry. Na-stuck up siya. Okay, so far, do you have any question? Any question? Class? Ayan. Okay. Yung flexural bars, okay, let me draw it here. Flexural bars will be dito. Okay. Ito yung mga flexural bars natin. So this flexural bars goes all the way up to there. Now, what about the temperature and shrinkage bars? They are perpendicular to your perpendicular sila sa flexural bars natin. Okay? So these are temperature and shrinkage bars. By the way, what are those in temperature and shrinkage? Bakit sila tinawag na temperature and shrinkage? Anyone? Bakit kaya?
Sir?
Yes.
Ali, I think it's because kapag po after setting, mag-shrink pa yung concrete kapag nag-dry na siya. So, yung pores po na yun yung mag-maintain ng length niya.
Correct. Correct yan. Okay, because in temperature, ito yung when there are temperature changes, okay, your concrete would usually shrink or expand or contract. No? That process, expanding and contracting, merong nagka-create na ano yan, na stresses. Na. So the tendency would be there will be cracks. No? If you won't have any reinforcement for temperature. Yung shrinkage naman, tama yung sinabi ni, sorry, is it Nicole yung nagsalita?
Yes.
Okay, Nicole. Yan o, kapag nag-set na yung concrete, siyempre mag-evaporate yung, yung water, no? To minimize no, yung shrinkage niya, we provide this. Isa rin yun sa use ng mga reinforcement na to, which are perpendicular to the moment reinforcements. No? So we will call those moment reinforcements because those are perpendicular to the temperature and shrinkage reinforcement. Okay, so malinaw yung direction ng mga ng mga reinforcement natin. Okay, so temperature and shrinkage reinforcements, these are along the length of our and maximum yes, Maximum reinforcement ratio. Reinforcement ratio is the ratio of reinforcement slabs grade 60 deformed bars. You have 0.018 reinforcement. Okay. Slab reinforcement with strength exceeding 60